All right, hi guys. My name's Kevin, and I want to thank you all for joining us today. Mihai just came in. As you can tell, we were trying to fix some technical issues, but I think we're going to go on ahead with this webinar today. So I want to thank you all for joining us in our latest Novedge Best the Best webinar series. For today's Novedge webinar, episode 58, Mihai Iliuta will show us how to light and render your designs in a virtual photo studio setting using Maxwell Render. We will approach the lighting from a photographer's point of view, looking at how to make different kind of emitters, depth of light, and how to post-process your images using Photoshop and different render channels. Maxwell Render Suite 2.7 is a physically correct, unbiased rendering engine, and it is capable of simulating light exactly as it behaves in the real world. Maxwell Render Suite 2.7 can fully capture all light interactions between all elements in a scene, no matter how complex they are, while offering a straightforward user interface and effective workflow through plugins to a large range of 3D and CAD applications. Maxwell Render Suite 2.7 has been acclaimed as a landmark in next-generation rendering technology, having produced the best photorealistic images to date, and continues as the leader in unbiased rendering for photorealistic imagery, advanced lighting, especially in architecture, interior design, product design, film, and TV production markets. If you had the chance to check out Maxwell Render's latest SIGGRAPH show reel for 2012, you should have been able to check out Mihai Iliuta's amazingly detailed work. For many years now, Mihai Iliuta has been a dedicated Maxwell Render user since the very first alpha releases in 2004. For the last few years now, he has been working for Next Limit Technologies to provide technical support and to oversee beta testing of Maxwell Render releases. We are all very lucky to have someone of Mihai's experience and expertise to join us today. This is looking to be a jam-packed and informative webinar, which I am sure our attendees will enjoy. That means all of you guys. Well, the presentation itself will be about 40 minutes long, and in just a bit, I will hand over the microphone to Mihai. If you have any questions at any time during the presentation, please post them into the chat window so we can answer them during the Q&A session. Today's webinar will be recorded live, so if you want to rewatch episode 58 in its entirety, as always, you can find it on our Novedge webinar series channel through Vimeo and YouTube. With that said, I will now turn it over to Mihai. Mihai, are you there?
Yep, I'm here.
All right. Cool. Let's see. What time is it right now over there in France, right?
8 o'clock.
Oh my gosh. Thank you for staying up late with us. I hope you had dinner.
It's not my bedtime yet, so it's okay.
Well, someone mentioned that the Celtics are playing today, so let's get this started. I will switch the presenter to you.
All right.
Let's see. Changing presenter now. Are you right, Mihai?
See, all right. Is that? Can everybody see that?
Yes.
Okay. Well, I'll just get started quickly. So we only have about 40 minutes, and we have a lot to cover. I just want to show you two renders which I'll be going through today, like a typical bottle render and this Nespresso machine. It's not going to be a basic Maxwell course because, well, there are too many things to cover in a basic course in 40 minutes. I just want to mention quickly that you have all the documentation here at support.nextlimit.com category Maxwell. You have documentation, and I really strongly suggest if you're a beginner with Maxwell, please read this section before you begin. Okay? It's not a lot here, but it's some very important details when you get started rendering with Maxwell. Okay, so first of all, about studio lighting, just made this quick PowerPoint to demonstrate what we talk about when we use studio lighting tools. And basically, we're talking about light modifiers. You want to control the light. You want to control mostly where the light falls, but in most cases, you'll find out you want to control where the light should not fall. So you have a bunch of modifiers called softboxes or reflectors, grids you can attach to softboxes, and all of these, their intention is to control where the light falls. So for example, a softbox is just basically a small flashlight here which illuminates this whole area here. So you have one small source of light which turns into a big source of light. And this is important because the bigger your light source is compared to your object, the softer the shadows are. Okay, this is one important detail about these softboxes. So to get started, I just want to show you quickly how I usually try to mimic these studio lighting tools in Maxwell Render, to use them in Maxwell Render. So here I'm using Softimage, and we have a good plugin for Softimage, so I thought I show that as well. But this is valid for any modeling application you use. If you use Rhino or Maya or 3D Max or whatever, we have plugins for about 14 different applications. So to get started with, for example, a light box, that's the easiest thing to do in Maxwell. You just get a grid, and usually when you emit light from geometry Maxwell, so in Maxwell all emitters need to be real geometry because you apply an emitter material to the geometry, and it's important that they're as low polygon as possible. Okay, so I'm just gonna set it to 1 by 1 polygon. So basically that's gonna be my softbox. Okay, so this thing here, it's going to emit light from this whole area here, so I'm going to apply a Maxwell material. And I'm going to add an emitter component to this material. And in this emitter component, you have different ways of specifying light strength. Okay, you have power and efficacy. So for example, if you want to mimic a 40-watt light bulb, these are your typical settings. So you set the wattage and the efficacy of that light, meaning how many lumens, which is a measure for light, how many lumens per watt of light does that light bulb put out. But usually I like to work directly in intensity because then I can specify the lumens directly. Okay, and for typical studio lights, you have about, I don't know, 1,000 to 10,000 lumens, something like that, in the range of those studio lights. So if I launch Maxwell Fire, so this is an interactive render engine, which is very useful for previewing your scenes before sending the scene for the final render. So you can see that as I increase lumens, I get more light in the scene. Okay, so that's a basic softbox, and you can see that it's pretty good because it's a huge light source, meaning you'll get soft, nice shadows in your scene. Okay, it's going to get a bit more interesting in this, just try and work as quickly as I can. And you can see that if I make this emitter bigger, I'm going to have softer shadows, and if I make it small, okay, the shadows are going to get a lot sharper. Okay, so the shadow softness depends entirely on how big the light source is compared to your object. Okay, so that's a softbox, and next I'll show you this modifier, for example. So this allows you to control more the light, to make it more focused. Okay, and the way to do that in Maxwell, this is how I do it in Softimage, but again, it's the same for any modeling application. So first I grab a cylinder, make the sides somewhat high polygon, not too much. Then I just grab the bottom of it, or sorry, grab the polygons at the bottom of it, detach them, so they're the separate object. Make it a little bit smaller so it doesn't coincide with the faces of the cylinder. Okay, so this thing here is going to be my emitter. So again, I'm going to add Maxwell material and add an emitter component to that and switch it to lumens. let's say about 3,500 lumens. And actually I'll apply a material to the cylinder as well, and I'll just make it black, because I don't want it to influence the light coming from the emitter. I just want it to eat up the light here on the walls. And let me just show you this. I'll parent the emitter to the cylinder, so now they both, when I move the cylinder, the emitter moves with it. Then I add a null object to the scene. So this is just a null object, it's not really geometry, it's just used for controlling lots of different things. And I'm going to constrain by direction this cylinder to this null and set it to the correct orientation. Okay, so what does that do? It allows me to now, if I move the cylinder around, it's going to always point at this null here. So for example, if I want to light up the sphere here at the top of the sphere, I place the null there, and then I can move the cylinder wherever I want it. Okay, I mean, you can probably have these constraints in other modeling applications. You probably have it in Rhino as well. I'm sure you have it in Max and Maya and Cinema 4D. So now if I do a test render, you can see a little bit how the light spreads now. And if I move this emitter back now into the cylinder, you can see that I'm getting more and more focused light. Okay, because this tube is used to focus the light. And again, I can move it around quickly to adjust where the light is coming from. So basically, these are the two light emitters I use most of the time to control where the light is. Right. So that's a little bit about modifiers. The rest of these, for example, reflectors, you can just use a grid with a Maxwell material that's set pretty bright. Diffusers, the same thing. You can use them instead of use a plane to diffuse the light. I mean, diffusers, they're used to make a small light source bigger, so you can just use this as the emitter instead, use the diffuser directly. Next, a little bit about how light behaves. This is important because it may sound a little bit techy, but these two laws, so to speak, will come in really handy when you do studio lighting setups. The first law, called the law of reflection, this says that the angle of incidence of light, okay, is equal to the angle of reflection. So if the incoming light is coming in at an angle of 45 degrees compared to the surface here, it's going to also reflect at an angle of 45 degrees. Okay, imagine this is a very smooth surface. This is important to understand, so I made an example here. So here I just have this really shiny plate, very shiny metal, and here I have this huge emitter. And if I render this, you're going to see that this shiny plate is completely black, okay, even though I have this huge emitter here in the scene. Okay, it's exactly because of this law, the law of reflection. Okay, because my camera is at this angle here, okay, the light really, when it shines, it's coming this direction here, and then it's going to bounce at the same angle as the incoming light, so it's going to bounce about here somewhere. And my point of view here, my camera is outside this angle. That's why I'm not seeing the emitter here in the reflection of this object. So what you would need to do in this case is either move the emitter or move up the camera slightly until we start seeing the emitter here. Okay, and now you can start seeing it. So this is all about this law of reflection, and you can use that lots of times to your advantage, especially when you're dealing with very reflective surfaces like this. Because, for example, if I increase the reflectance, if I increase the strength of this emitter, I can increase it to whatever I want. I'm just going to influence the background here, or the backdrop, without influencing the lighting on this object here. It's all about these law of reflection. For example, 500,000 lumens. Okay, you can see the background is just completely white now, but this stays exactly the same. So this is valid for any specular surfaces you have. Just remember this law of reflection. Or for example, if I move the emitter down, now I'm going to start seeing it without moving the camera, because the angles now correspond to both the position of the emitter and the position of the camera. Now, in this scene, for example, I have in the backdrop here, it's sort of a cloth material, or it's supposed to be a cloth material, but you don't really see the bump in it. Okay, so one tip I can give you is when you want to bring out the texture in something, like cloth or any kind of texture, use a smaller emitter. You can see it here, and place it below to that surface. Okay, so if I do a render of that, you can see that now I put the texture here on the ground compared to just a huge buff, which is not going to bring out the texture in your back, and still it's not influencing the lighting here on the flat part, because it's outside the angles here. Okay, I think I have a render here just as an example. So here you can see just with the flat emitter at the top, and here with that small emitter at the sides. Okay, you can see much more texture, and it looks a lot more interesting than this one, just with that small emitter. Okay, now another type of emitter I wanted to show you before we move on to those two scenes is something called an image emitter. So, for example, let's say I move up the camera here. Okay, so you can see that I get this reflection in the metal, but since this softbox is just completely white all over, I get this sort of fake or not so realistic reflection because it's all white. And what if you wanted to sort of fade the intensity of the reflection, or fade the intensity of the emitter across the surface? So in that case, you need to use something called an image emitter. And I'm going to show you how you can do that in Photoshop. And we're going to add it to this plane here. Okay, so you can see that the emitter here, if you switch it from custom to HDR image, so high dynamic range image, you can load an image here in this slot. And that's what we're going to do. So I'm just going to start a new image in Photoshop, and it doesn't have to be too big, about 1000 pixels, it depends. And make sure you set it to 32-bit though, not 8 bits or 32-bit, because we're going to work in high dynamic range when we create the emitter. Actually, I have a render cooking here. I'm just going to stop it. Okay. That's going to be for later. So, first thing is first, we're going to draw a gradient from the center of the image outwards. And so this is going to be like a softbox that's not turned on. And I'm just going to turn on the rulers here. So just press Ctrl R and click and drag on the ruler to drag guides here. And they snap in the middle because I have snapping turned on. And then switch to the gradient tool. And the important part here is that you first set an initial value here for RGB to something like 0.2. Okay, so this is going to be our base emitting surface. You'll see what I mean in a minute. So I'm just going to drag out a gradient here, just a little bit outside of it. So I get these black borders here. And then I'm going to add a second layer, and this time I'm going to increase the value of this white. Okay, so remember, we're working in high dynamic ranges here, so this can go as high as you want, basically. But I'm just going to keep it to 0.8. I just found out that works pretty well because I'm trying to mimic this hotspot in the middle that gradually fades out. You know, just like a real softbox, because you have that strong light source in the middle, and then it gradually fades out at the softbox corner. So that's what I'm trying to mimic. So I'm going to drag out a smaller gradient here, so like that, and set it to linear dodge mode so that these two get blended together, and then just merge those two layers. And then probably we need to blur it a little bit, or a lot, depending on the look you're going for. So maybe something like that. Okay, so that's going to be our softbox. And you can see now, if I change the exposure, you can see how that virtual light changes. So we have that hotspot in the middle. Okay, and then just save that. In either EXR or HDR formats. Okay, so either HDR or EXR. Let's save it as EXR in this case. And in my emitter material, I'm going to apply that to the emitter here. Just like so. And switch it to HDR. Oops, I forgot to add UVs to this. Okay, and by default you can see the intensity set to 500, and in this case it's much too bright. I'm going to set it at 1. Okay, and you can see that hotspot there, which makes a little bit more interesting reflections in your objects. Okay, so with HDR emitters, you really have a lot of freedom to create exact light sources. You can draw any in Photoshop. To remember to 32-bit. Okay, so when you create your image, create it in 32-bit, not 8-bit, and play with different intensities and so on to create these kinds of emitters. Okay, so quickly moving on. The next law here, the inverse square law. This is also a really important thing to get nice renders. And this says that light strength diminishes to the square of the distance. Okay, so in this render here, I have an emitter here and a plane. And let's say that the plane is 10 meters. Okay, at 1 meter, I have a certain strength. Okay, at 2 meters, the light strength is actually going to be 4 times weaker than at 1 meter. Okay, at 3 meters, it's going to be 9 times weaker, 4 meters, 16 times weaker, and so on. Okay, because it diminishes by the square of the distance. Now, this is really important because you can also use this to your advantage by placing, emitters closer to your objects without influencing the rest of the scene. Okay, and emitters in Maxwell by default follow this inverse square law, which is nice. It's not a setting you need to change. And just show you an example of that. And how you can use that to your advantage. So here I have a very simple scene with a huge emitter on top. Okay, and let's see what that looks like. Okay, so I mean, it looks so-so. We get nice soft shadows, except that it doesn't look too interesting. I mean, there's no contrast in the image, and that's really what makes an image look interesting, is the contrast. It's the difference between light and shadow in your render, because that's going to bring out the form in your render. Okay, for example, this bowl here, it's supposed to have these bent edges here, but here they just look flat. We don't really see that. So by following that inverse square law, let's move, first of all, this emitter closer to this bowl. Make it a little bit smaller. Just rotate it around. Okay, you can see the nice instant feedback we get from Maxwell Fire. By the way, this stands for Fast Interactive Render Engine. Okay. Now, because I moved this emitter closer, it's much too strong. Okay, because of this inverse square law. So I need to make it a little bit weaker. Just so I have a nice exposure here, just on this this bowl here. Okay, you can see just by moving the emitter and moving it closer to this bowl, I created some interesting contrast in the scene. I see the shape of the bowl now much better. I can see better the shape of these ears here, and also these bottles have a lot less light on them, just so they sort of not contribute as much to the viewer's attention as the bowl here. They just add a little bit of stuff around the scene to fill out the scene, because they're farther away and the emitter is so close to this bowl. I'm going to get a lot stronger light here on this bowl than on the bottles. Okay, so this is what we mean when we talk about depth of light. It's really this inverse square law and how quickly the light falls off with the distance. Okay, so enough of that. Let's get on to the fun stuff. So in this scene, we're just going to quickly recreate this render here. So first, I just have a plane that the bottle sits on, and this plane has a reflective material on it. And this material is really simple. The only thing I did was actually change the surface roughness from 99, which is it by default, which is going to give you a diffuse surface. So just change it to about roughness of 2, which is going to give you a reflective surface. So it's going to reflect the bottle there. And this is just a gray material, which has a high roughness. So it's going to act like a diffuser, basically, of light. And right now we don't have any emitters in the scene, so I'm just going to import my little cylinder there with the light. So I really suggest you do this, that you build your own lighting tools and that you can just quickly import these into your scene. So that's the cylinder with the emitter inside. Move that out of the way. And again, I'm going to add a null. And I'm going to parent or constraint the cylinder to the null. So first of all, I'm going to work on the background lighting. Maybe I want it to shine there. Okay, so this light, it's going to be the background light that you saw in this glowing light that's behind the bottle. So if I render that, you can see that now we have the cylinder casting the light on this background here. So for example, let's say I wanted to have more focus light, I just move this back. You know, now I have maybe a bit more dramatic lighting. It's fading out at the edges, and of course I can make this smaller. You know, so with these kinds of light modifiers and Maxwell Fire, you can really work quickly to set up the exact lighting that you want. So maybe something like that. And the bottle is black because right now it has just a gray material as well. I'm just going to go quickly through creating a glass material for this bottle. So again, we don't have time to go into details about the Maxwell material system, so I just going to show you quickly how easy it is to set up a glass. So to set up a glass, you need to make sure that transmittance is something else than black, because transmittance controls, you know, the transmittance of light through an object, how it goes through an object. So for example, if you want a blue glass, you set this to blue, and then change the attenuation distance to something like 25 centimeters for glass. And the attenuation distance controls how quickly light loses its strength as it goes through an object. So before it was set to nanometers, so 25 nanometers, it means it's basically going to look like a solid. So I set it to 25 centimeters. And also change the surface roughness from a very high roughness of 95 to maybe 0, which is, you know, very smooth glass, or you can have a sandblasted glass by setting the roughness to 10 or even higher. Okay, but I'm just going to set it to 1 for now. And by the way, when you work with really specular materials, try to avoid setting the roughness to 0, because that means, you know, it's a perfectly smooth mirror surface, and those surfaces really don't exist in the real world. So always start at roughness 1, even for, you know, what would be a perfectly smooth mirror finish in the real world. Just adds that little bit more edge of realism. Right, so that's the glass, and it has a yellow liquid inside. I'm just going to change the exposure of my camera because it's a little dark. And so the Maxwell camera works just like a real camera. If you're familiar with photography, you're going to understand these f-stop, shutter speed, film ISO. If you're not, just take a look in the docs, because the camera section is really detailed and it explains all these settings very well. So I'm just going to change the exposure by, for example, setting the ISO higher. Maybe even more. Sort of like that. And now again, if I want to make this glass look bluer, I can increase the saturation of the transmittance color, and at the same time I need to lower the attenuation distance so that the light, you know, has time to attenuate going through this the walls, the thin walls of the bottle, for example. But I'm just going to set back to just a slightly blue tinted glass. And so finally, to add this, you know, line of reflection here, I'm just going to add another grid. And I'm going to add an emitter material to it as well. Let me set it to about, let's see, let's try 2000 lumens. Somewhere like here. So being in a virtual environment, we can do stuff that a photographer couldn't do. For example, let's say you wanted this reflection to be exactly in the middle of the bottle, but you can't put it in the middle because you know, it's going to stand in front of the camera. What you can do is cheat a little bit and add a property to this object that tells it to hide to camera. Okay, so now that emitter will still influence the lighting in the scene. It's still going to cast shadows, light in the scene. It's still going to be reflected on that bottle. It's just the camera is not going to see it. So in that way, you can really place the emitters exactly where you want them to be. Maybe twist it around like that. Make it a little bit bigger. And maybe not quite so strong. Right. Okay, so that's our reflection in the bottle. But you can see a problem here is that it also influences the lighting on the background here. Now, if we don't want to do that, but still could keep the same look, we can use that inverse square law to our advantage by moving this plane further back, so that now the lighting that's coming from this emitter, it's hardly going to influence anything on this plane here because it's too far away. And then we can just move our bottom emitter closer to it so we still keep that lighting nice on the background. It's the same. Now you can see that it's gotten a lot smaller here in the reflections of the glass, so I'm just going to make it wider to control where these dark edges are going to be. this forward a bit to make it a little bit more diffuse in the background. Right? So anyway, even though it sounds a little bit techy, you see how you can really use this to your advantage if you know what it means, and to control every aspect of the lighting in your scenes. Right. So I think I have about 10 minutes left, 15 minutes left. We're moving on to the Nespresso machine.
It's all good, Mihai. You can take as much time as you need. We just want to make sure we have enough time for the questions as well. So it's all good. No worries.
Okay. Good. So this scene, I'm just starting with the background lighting. So again, I'm not going to go through every material for the Nespresso machine and all that stuff. You can find plenty of info in the docs for it. Just to concentrate on the lighting, so here I have a backdrop, just bent like that, and you know, if you want a more diffuse light fall off for the background, you can make this bend a bit more, or if you want a sharper fall off, make this bend, you know, smaller. And here I'm using the same principle as the cylinder emitter. So I put an emitter inside here, inside this box, which I've constrained to this null here. That's here. So the purpose of this is just to first light up the background, because we want to get this look of you know, a white background, a completely white background that sort of fades into this reflection here. So everything is supposed to be more or less white, but we're still going to get a hint of reflection that this object actually sits on something. So at the bottom of it, I added just this plane with a plastic, shiny plastic material on it. So if I do a test render of this, you can see that because this emitter sits inside this box, and this box blocks any light from this emitter that falls on the coffee machine, you know, I'm just starting by lighting the background and getting the background white. So I can do that either by changing the strength of the emitter or changing the exposure. I guess in this case I'll just change the exposure. Or actually not. I'm going to change the emitter strength, because I want to keep these parts of the espresso machines dark, because I want to use other lighting for this part here. I don't want the lighting from this to influence the espresso machine at all, or as little as possible. So I'm going to increase that till I get something that's mostly white. Move it a bit. So it's just an even white in the background. Okay, so now that I have this set up, I can start working on my other lights. So this is another aspect which is important. Don't, you know, first put emitters all over your scene, 15 emitters, and then try to tweak each of them without knowing exactly what it does, where the light falls from it, and so on. Just work step by step. It's really the best way. So then I'm going to add another grid. Which will be an emitter from the top. So like here somewhere. add an emitter component to this material. And again, I just like to work with lumens directly. I just find it more, quicker than trying to work with watts and efficacy. Some lumens. Okay, so there, and nothing happened now. And why is that? It's because the normals of this plane are pointing upwards. Okay, let me switch on normals. Okay, you can see these blue arrows here. The normals are really the direction of the polygon, and it's important to keep in mind in Maxwell, the light is going to be emitted only in the direction of the normals. So I just have to flip the normals of that emitter, and now I can see the light falling in the right direction. Okay, so keep this in mind because we get a lot of beginner users have problems with this because they don't see any light in their scene and they wonder why. Check first of all that the polygons are pointing in the right direction, that the normals are in the direction that you want the light to fall. Okay, so that's basically going to be the main light here, and it's already looking pretty good. I get some nice contours here at the front. Let's see if we move it really down. So for example, now I just made it smaller because I wanted a smaller highlight here on the front. So it's just a matter of experimenting with one light at a time. Okay, so now, for example, I made it bigger, and now the highlight here is bigger on this rough plastic. And I think that looks a little bit better. And next, I'm going to add an emitter that's going to light the right side here of this milk froth thing. Just add a little bit of contrast to bring out the shape of it. So another grid. Make it pretty small. Add an emitter again. Let's make it pretty weak because we just want to add some highlights. We don't want to blow out the entire scene. Point it in the right direction. Okay, so there you see how it just lights up that side really nicely. It brings out those little waves of that machine. And you can see that I'm working with these emitters pretty close to the objects because that allows me to have a pretty weak light for this emitter without it influencing, let's say, this side over here. Again, the inverse square law. If I place it too far away, in order to have a highlight there, I really have to boost the intensity, but that's going to influence too much this side. It's just going to blow it out completely. Okay, so generally try to work as close as possible with your emitters, especially if you're dealing with smaller objects and you want to control the light. Okay, maybe even smaller. I'm going to tilt it up more so that I can get more shadow from these little waves here. Yeah, something like that. That looks great. Now we can really see that it's the shape of this milk frother. And now we're going to cheat again because you can see that the emitter is now in camera view. So I'm just going to add a property to it to hide it from the camera. Which is really nice. Okay, and now the last thing I want to add to this is a little bit of highlight here, because this is just a black here. It's just reflecting the blackness of the scene because we don't have anything there. So I'm going to add a third grid. And actually, I'm going to use that softbox emitter because I don't want just a white blob of reflection here. I wanted a little bit of fade off. So I'm going to use that softbox I created earlier. So in that case, if I want to use a texture, of course, I need UVs. So I'm going to add some UVs to this. Add an emitter component, switch it from custom to HDR, and I'm going to drag in that softbox EXR that I'm in Photoshop. Okay, wow, that was that was nice. That's because the intensity, again, by default is 500, which is a bit high. Probably we need this to go really low. Yeah, 1 again. And now it's just a matter of gently moving it until we get the highlight from that bright center. Okay, sort of like that maybe, and I'll lower the intensity even more. Right, that's too much. Yeah, it's something like that. Okay, and final thing, well, this is turning out a bit too white now because of this top emitter, so I'm going to lower the strength of it a little bit so that we get back these reflections here. Maybe a little bit more. And now I just need to move this maybe a little bit closer because we get that dark edge there. Okay, to something like that. So now when you're ready to render, just stop Maxwell Fire, and from the render options, I'm going to set the sampling level pretty high. So sampling level of 20, you're rarely going to need this for product renders. It depends on the type of materials you have, but mostly maybe 17 or 18 is enough. Okay, and then I set the time really high because Maxwell is going to stop when either the sampling level is reached or the time is reached. So if you set the time high enough, you'll know that it's not going to stop rendering until it's reached sampling level 18. Okay, so these are the kind of settings you use for final render. If you want to do a test render and you just want it to take 5 minutes, then just set it to 5 minutes and leave the sampling level at 18 because there's no way it's going to reach sampling level 18 in 5 minutes. But for the final render, these are the kind of settings I use. And finally, in the channels, I'm going to turn on the material ID. Now the material ID is going to render an extra image which is going to give you a color image, which it looks like this. Okay, for every material in your scene, you're going to get a solid color of your objects. And this is very useful in Photoshop when you want to make quick selections to just adjust some of the materials. For example, I want to make this red, I want to make it maybe a bit darker or more red. So the material ID channel is really great for that, and it's exactly the same thing for the object ID, except you're going to get those colors based on all the different objects in your scene. So here's something I prepared earlier because we wouldn't have time to render it. So anyway, this rendered for 35 minutes on my machine, and you can see that it's reached sampling level 15 in 35 minutes, and it's pretty okay. I mean, it's still a little bit noisy, but for our purposes, demonstration purposes, it's going to be okay. And when Maxwell renders, it outputs those image files, which you can decide what kind of image files from the render options. This is what it looks like in Softimage, but in your application it might be different. Just check out the docs because we have documentation for all the plugins as well at the same URL. In this case I render to TIFF, so it's going to give me a TIFF, but it's also going to give me a so-called MXI. Now an MXI is Maxwell's proprietary image format, which is a high dynamic range format, and the good thing about it is that it allows you to do lots of cool stuff after you rendered. For example, you can change the exposure during or after you render. You can use something called multi-light, which is actually a real shame because I forgot to switch it on when I rendered this. But it's also from the render options, multi-light. Actually, I can actually maybe render a small test. You can see this. Okay, so now I sent the scene to render, it starts to render, and you can see now with multi-light on, I have a slider for each of the separate emitters in my scene, which I can then adjust as I want or solo them to just see the influence of the lighting from those emitters. Okay, and I can do that while Maxwell is rendering, or I can also open an MXI that I rendered before, and I still get those sliders and I can adjust the lighting as I want. So this is a really cool feature because it allows you to really fine-tune the lighting without having to re-render your scene. So for example, let's say I change the mood completely. Make it a lot more dramatic. so I get a completely different render from the same render using multi-light. So this is another advantage of the MXI5 format. Another huge advantage is that you can also open it in Photoshop. We have a plugin for Photoshop to open these kinds of files. Okay, so when you open it, it's going to ask you, do you want to open in 32-bit, 16-bit, or 8-bit? I usually open them in 32-bit because you have the most latitude, so to speak, to do editing with the images. You can change the exposure in 32-bit, and it's going to react really nicely. Okay, instead of you were to open it, let's say in 8-bit, and now if you want to change the exposure, it's going to look completely strange. Let me see. Okay, I'm going to take that back. Right, so here you see when I open the MXI, the plugin imported also that extra ID or extra channel, which was the material channel. Okay, so now I can, in Photoshop, I can use the magic wand to select just the portion of red, for example. The one thing is that Photoshop doesn't seem to support the magic wand in 32-bit, so you have to switch it to 16-bit. And now I can select quickly just the red material. And for example, let's say I want to adjust the hue. So you can see I automatically get a mask from that selection, and I can make it a brighter red. I'm just influencing that part of the render. Like so. So there's a lot of tweaking you can do in Photoshop directly by opening up the MXI file. Or of course you can also open the TIFF file by itself. Sorry. And work with that and import the ID separately. Bring in the ID and you have the same thing. But I just find it lots of times it's more convenient just to open the MXI directly. We have all the extra channels already. Finally, another important thing to keep in mind when you open the MXI or when you're dealing with any rendered image in Maxwell is that when it's rendering, it saves the image in something called linear space, meaning that there is no contrast adjustment, or there is no tone mapping. It's just a linear tone mapping, which means that you always have to add a little bit of contrast to your renders to make them look a little bit nicer. So to do that, I usually add a curves adjustment layer, and for example you can use medium contrast. Okay, and you can see that looks much nicer than the linear tone mapping. Or you can save your own presets. I have a preset here. Okay, you can see it looks a lot nicer. Right, so I think that about wraps it up. I don't know how much time I have left. Hello?
Yeah, hey, sorry about that. I've got a little cough here. Shall we get started with the Q&A session?
Yeah.
Okay,
yeah.
Let's take about 10 minutes for this. I assigned some questions to you, Mihai. Let's go over them. Let's see. Let's give
yeah. Oh, actually I had a little bit of tips. Some tips I wanted to mention.
Go for it.
Especially for beginning users who are watching. Please keep in mind that the default exposure settings, okay, in the Maxwell Camera, they're set for daylight. So if you do a daylight render, things are going to look properly exposed. But if you try to use those same exposure settings for typical studio lights, you're going to see that you're mostly going to get a black render. So in that case, don't be tempted to set your emitters to hundreds of thousands of watts, because you're going to have all sorts of problems with that. You're not going to know how to deal with the lights. You may have more noise and so on. So adjust the exposure of the camera instead. Right. Well, about the contrast, as I mentioned before, try to get, the lighting. Don't light all of the all of your scene equally, because that's going to make the most boring result possible. Always try to bring out the shape by using contrast. The difference between light and shadow. For jewelry renders, the problem you're going to have is keeping the object in focus because they're so small. So in that case, use a high f-stop, but usually don't go above f-stop of 50, because there are really no lenses that can go higher than 50 f-stop. So if your object is still out of focus, then you can double the scene scale. In this case, it's not going to influence the look of your materials or lighting so much, even if it's faking it a little bit. Voila, that's all.
Okay, cool. Okay, there was a jewelry question. I hope that answered that a little bit. But here we are. Let's start with the very first one. Okay, this is from Anton. Anton wants to know whether or not you can use the null point trick in Maxwell Studio.
Sorry?
Can you use the null point trick in Maxwell Studio?
I'm not sure what that means. Null point trick?
The N-U-L-L? Yeah.
Sorry, I don't know what that means.
Okay, in that case, Anton, we will be posting these questions.
Null.
Oh.
The null trick.
Yeah.
Oh, sorry. In Studio, no. You can't do that in Studio. You don't have any constraint functionality. I mean, Studio is not a modeling application. That's why I prefer to use Softimage. But I mean, this is pretty standard stuff in Maya and 3D Max. I'm sure Rhino must have it, some sort of constraint that you can constrain an object to another. In SolidWorks as well. Right. Yeah.
Okay. This one's from Thomas. Do you use a diffuser for Sss-Material?
No, I try to avoid that because it adds a lot to the render time. I mean, of course you can do it really realistically, and I can place a small emitter here on this side and set this plane so it needs a thickness if I want to use subsurface scattering, or thin SSS. In that case, it doesn't need a thickness, and you're going to get a realistic effect. But I mean, it can add a lot to the render time if you do that, especially with volumetric SSS. So I just usually fake it using these HDR images. It's sort of the same effect, basically.
Cool. Okay, this is...
It would be nice if the render times were much longer.
Then you would need a supercomputer, I'm sure. But, okay, this is from James. James wants to know, will there be a chance to view the images used as examples after this session? And I think there was another audience member who was asking about documentation afterwards as well.
Well, I don't know. I can upload the PowerPoint somewhere in the renders. If
cool. If you guys can...
the renders or the scene setups?
Maybe the... probably the renders. Maybe both. Okay. Yeah, both would be great.
I can do some screenshots and send you a link to it. You can send it to them.
Okay. I'll also probably put that information on our video page, and that way they can get it from you guys too as well. So. Yeah. Cool.
Yeah. I know I went through this stuff a bit fast, but it was so much stuff to cover. So. Yeah.
Okay. Here's another one. If I stop the rendering, how can I later continue the rendering? This is from Alan.
Oh, that's really easy. So here I stop the render at SL15, and as long as you don't change anything in the scene and you don't delete that MXI, all you do is click render again, and then Maxwell knows that you have an MXI there with the same name, and it asks you, do you want to restart or do you want to resume? So I just press resume and it starts from where it left off, and that's it.
Sweet. Okay, this is from Dominic. Dominic wants to know, what kind of camera setups do you use for such studio setups?
Well, basically, I mean, what's going to influence your scene or how your object looks is the focal length. Maybe I should show this better in studio. Let me see. Okay, so now I'm looking through my camera, and usually for studio photographs, you don't want to have too exaggerated focal lengths, meaning you don't want to go like super wide angle, because that's going to completely distort stuff in your scene, unless you want that dramatic look. And the opposite, you also don't want to get too high focal length, meaning this is like a zoom lens, because that's going to flatten your perspective. So here you can see we don't really see that. It's a 3D cube. If I clone it, move it to the side, I don't get that impression of depth of how far back this cube is compared to this one. So if I set it back to normal focal length, which is about 35 millimeters or 50 millimeters, that's the most common focal length to use for studio shots. Yeah. Next.
Okay, let's see. All right, okay, this is pretty simple. This is from Emilio. Where can we find more Maxwell Studio lighting resources online?
We don't have any ready-made scenes, so to speak. We probably be a good idea to add those to the docs, but as you've seen, it's not such a big deal to do these yourselves. It's just a matter of placing them right. It's very simple geometry. I'm not sure if you have some here. No, I'm sorry. We don't, in the knowledge base, I don't think we have any lighting setup scenes that you can import in your scenes or studio setups, but hopefully you can quickly do them yourself.
Yeah,
Doesn't take too long.
Yeah, good luck with that. And let's see. Let's see. Here's another one by Thomas. Well, good evening, Mr. Iliuta. I would like to ask about glass and liquid interaction. What is the correct setup for faces of meshes?
Oh, this is a tough one. We had long discussions about this on the forums, but I can show you quickly this bottle, liquid in a bottle that I did. So, well, the correct way would be actually two different meshes. Okay, so this is the glass of the bottle, this is the liquid. And what you need to do is actually model the liquid. So I first modeled the bottle. It has thickness in the walls. Okay, so it had a real thickness, like a real bottle. And then I just selected part of the interior wall of the bottle, extracted that into a separate object. Then I capped the hole here. So this is my liquid, and the normals here are supposed to point outwards. And that's basically it. So you have the hollow bottle here and the liquid inside. And just don't forget to invert the normals here so that they're pointing outwards. So outwards like that. Now this is necessary because imagine a light ray goes in like this into the glass, And actually, let me put the liquid inside again. You can see it better. Okay, so light ray hits the glass here. So Maxwell says, okay, I've hit glass, now I'm inside glass. And then if the normals weren't inverted here for the liquid, it would just keep on thinking that it's inside of glass. Okay, and while it reaches this side, suddenly it sees a normal of the liquid pointing this way. So it says, wait a minute, now I'm entering liquid, but I'm still inside glass. And then it thinks it's inside liquid. And then when it goes outside of the glass here, I'm outside of the glass, but I'm not outside of the liquid because it's entered the liquid here. Okay? So by inverting the normals of the liquid, Maxwell knows that, okay, I've entered glass here. Now I'm entering liquid. I'm still inside glass. I'm traveling this way. Now I see the normal pointing this way, so I know that now I'm exiting the liquid. I've entered liquid here, I'm exiting liquid here, and here I'm exiting the glass. Okay, so in that case the refractions are going to be correct in this case. This is a little bit complicated for beginner's course, but anyway,
yeah.
I hope some of that made sense.
Yeah, so just going to skip ahead, guys. We have a lot of questions, and if you guys have questions, please head on over to Maxwell Render's forums and community pages, register with them, and ask them, and then I'm sure they will take the time to answer them as best as they can. But let's go over some of the more simple ones. Let's see. Okay, how would you best render with the camera underwater looking out towards the surface of the water? This is from Brian, by the way.
Looking out towards the surface of the water.
Yeah.
Ooh, that's a bit of a tough one. I think I would put the camera inside a sphere. So basically mimic that the camera is inside an air bubble. Then if the camera is animated, just parent the camera to the bubble, but always keep the camera inside the bubble, because again, Maxwell doesn't know if the camera is inside water, if it's inside a volume, it can't know that it's already inside water. Okay, so imagine this is your cube of water and the camera is inside there. So with Maxwell it sends out rays both from the emitters and the camera. So if an emitter ray, if a camera ray goes from the camera outwards, it just knows that it's sort of exited water, but it doesn't know that it's inside the water. So put the camera inside a sphere, and yes, I guess I'd set the sphere to have a thickness, set it to be transparent, but set the index of refraction to 1 so that it behaves like air. I think that should work correctly.
Okay, yeah, I hope that works as well. Okay, one last question. Okay, let's see. Is that any different in image quality? Is there any difference in image quality using Maxwell emitter versus HDR image from HDR Light Studio? This is from Y.
No, there's no inherent loss in quality. The only thing is that both of those approaches have their advantages and disadvantages. If take a look at the Nespresso here. No, not that one. This one. Oops. Well, it crashed. Well, yeah.
Okay.
XSI crashed. No, but I just wanted to show that with HDR Light Studio, all your lights are at the same distance. So you can't do the stuff like for example, in this case, I just added an emitter close to this object, and I have more light control because I can control the placement of the lights depending on the distance of the object. If you're using something like HDR Light Studio, because it's an HDR, so it's a huge sphere around your scene, you can't control really the light by this light fallout and the distance from the light to the object. But I mean, it's still a very useful tool, and in many studio setups, you can get great lighting from HDR Light Studio. So it's not really a matter of rendering quality per se, it's what you want to do with your render. I mean, in many cases, it's much, much faster to use HDR Light Studio than setting up emitters and so on. And another huge advantage is that with HDR Light Studio, when you create a new emitter in that HDR, Maxwell doesn't have to re-voxelize the scene. Because when you use real emitters, as soon as you move a piece of geometry, Maxwell has to re-export and re-voxelize the scene. And if you have a heavy scene with heavy geometry, that can take a little bit before you actually see anything with Maxwell Fire. Yeah.
All right, that's cool.
It was clear.
In that case, I will switch over the presenter to me. Let's see. I'm going to make myself a presenter now, Mihai.
Okay.
Cool. All right. I want to thank Mihai from Next Limit Technologies for coming out tonight to speak with us today. And I want to remind everybody that you can learn more about what Maxwell Render can do for you. If you want to, feel free to head on over to check out their website at maxwellrender.com. There you can find detailed product information and answers to all your support-related questions, and you can learn more about the product itself. Specifically, as we talked about and mentioned earlier, you can check out the wiki page here at support.nextlimit.com, where you can find the latest plugin documentations, a knowledge base with answers to common issues, and an area chock full of tutorials and techniques for interested users. So for new and old users of Maxwell Render, and I'm sure some of us wanted to learn more about hardware configurations, you guys can head over there to check it out and bookmark it for sure. Now, if you want to purchase your own copy of Maxwell Render Suite 2.7, you can visit our website at novedge.com. As a leading graphics and design software store, we have some of the best prices and are constantly in search of high-quality CAD and CAM solutions that enable you to do your best work. If Maxwell Render Suite 2.7 is your ideal rendering solution, you can speak with our specialist Bob at novedge.com. At Novedge, we created communities where users can meet, network, and catch up on all the latest industry happenings. We created WikiCAD, Vectorworking, and Rhino Jungle as that online place where you can collaborate and communicate with other like-minded professionals. On all three communities, we scour the internet for the latest industry buzz to share with you. Furthermore, we encourage community members to help each other excel in their career through discussion and submitted content. The process to sign up is a breeze, and with that, you have access to a weekly community newsletter. For access to discussions that matter, sign up and register today. Lastly, you can follow us on Twitter at our handle at Novedge Store, where you'll share with you the latest buzzworthy industry news, trends, and promotions. You can follow us and join the conversation at Novedge Store. If you have any questions, comments, or concerns about Novedge or about today's webinar, please don't hesitate to email me at kevin@novedge.com. For our upcoming Novedge Best of the Best Series webinar, episode 59, the co-eventer of HDR Light Studio, Mark Zagaspy, introduces you to the latest iteration, number 4. You can learn how to light your shots precisely and easily using HDR Light Studio number 4. Create a custom HDRI image on the fly containing all of your lighting and reflections. See how the new Light Paint feature revolutionizes the lighting workflow, allowing you to light shots faster than ever and giving amazing quality to your final rendered solution results. Registration is free, but space is limited, so for more information on how to sign up, you can check it out at novedge.com/webinar/59. And if you want to rewatch episode 58 and all our previous webinars, this and past webinars can be found on our Novedge webinar series channel through Vimeo and YouTube. So stay tuned over there for this one, which will be uploaded tonight. On behalf of our team at Novedge, I want to thank you guys for watching, and have a good one. Enjoy the game.